Welcome back. This is the second lesson recording for IM1, April 16th, 2021. Now we're going to go on to sketching reflections. Before we do that, I'm going to show you some resources that I would like you to click onto as well in the chat, and that will lead you to this site, okay? And it gives you some more information on reflection and give you some more additional examples as well. So reflections are everywhere in mirror, glass, here on the lake. What do you notice? So do you see a reflection of the image of the mountain, even with the snow cap on the lake itself? Okay. What else do you notice? Well, you should notice that every point in the same distance is in the same distance from the central line or the line of reflection. So the line of reflection, the line at which it is being reflected over is that brown land line, right? And it is reflecting over that black line if I was to draw that. The distance from each of the image, the original image, where the snow cap starts, as well as on the reflected image, is always going to be the same. Same thing with the tip of the snow cap, right? So the distance from the line of reflection for the corresponding point on the image is always going to be the same, as well as the reflection has the same size as the original image. And the central line, or the line of reflection, is called mirror line sometimes, or line of reflection. And that mirror line can be vertical. Here you can see a picture of a dog where it's a mirror image of left and right, or it can also be diagonal. Okay, and again, reflection is a flip over a line, and you get to play around with this again a little bit, where you see the horizontal line of reflection, and depending on where that line of reflection is, it changes the location of reflection. Notice that the orientation is always going to be a reflected image, meaning that the orientation has changed. Here the original image is this. Okay, it looks like it's pointing to the top right. Now the reflected image is pointing to the bottom right, right? So it is the reflected image, and depending on where the line of reflection is, the location of reflected image changes. And I can do that for the vertical line. Again, the orientation, the original image looks like it's pointing to the top right. The reflected image is pointing to the top left. And I can also have the diagonal line of reflection like so. And again, as you move the diagonal line of reflection, it changes the location, but the orientation is also changed. And that really depends on the line of reflection. Okay, so now you are going to be working on decimals, card number 2 to 5, but we're going to do it one at a time. So we're going to do it together as a class. And it's going to look like this. Card number 2 is asking you to trace image and blue line onto the tracing paper, then reflect the traced image. It's kind of hard to demonstrate this very well, so I'm going to do it on a paper. And those people who are here in person actually get the advantage of having a paper copy of this. So yeah, sorry. But those of you who are at home, you have to do it on decimal so that I can see your work. Here we go. How do we do this? The first thing is it says to trace the blue line. The blue line is actually this line. And then trace the image. Okay, I had a hard time doing this on Desmos itself just because it was so sensitive to my pen. Okay, now that you've traced the image, okay, so you are going to follow the paper along the blue line of reflection. So I am going to move it for the right bit here. And let me just put that back on top. And then you are going to flip it over And do you see where the trace image happens? Then from here, you are going to find your point. Okay, and you can see, so find the vertex, and then mark it. Okay, so I have drawn the two vertices, and then I marked it like that. Okay, and then I am going to draw that vertex. Let's see if I can see it, like so. And I drew that. And you do the same thing with all of them. Okay, so that's not quite right. Maybe about here. Good, that looks better. So I'm going to draw that. And then I am going to draw that vertex right there. And then I am going to draw this point right there. Check it. Okay, so here we go. So I've done that. Okay, you might find it easier because this can move up and down. You might find it easier if you actually drew a perpendicular line as well, so that you know that vertically that's where it should match up. Okay, so here again, I've traced my image onto my tracing paper and my line of reflection, and I folded it at the line of reflection and then flipped it over like so, and then find the corresponding vertices underneath and then drew over. Okay, this might be a little bit more tricky for you to do on Desmos because it is a lot more sensitive and so on. I am sorry that this was the whole reason that we pushed off the transformation as late as possible, hoping that everybody will be in person, but it looks like this is the best we can do. All right, so what do you notice about this reflected or flipped image? It looks like, if you can picture this as sort of an arrow, it looks like this original arrow is pointing to the right. The reflected image is pointing to the left. What do you notice about this distance? Okay, the distance, if I was to draw a perpendicular line from this point to here, this distance is going to be exactly the same as this distance. Okay, it's going to be exactly the same. And same thing with all the vertices, because that is the nature of the reflection. But this line that you're drawing, it cannot be at an angle. If I draw a line like this at an angle, that does not work. It needs to be a perpendicular line. So this distance from here to there is going to be exactly the same as this distance right there. So I'm going to use two notches to indicate this length and this length are exactly the same. And that is true for each one of the vertices of the original image to the reflected image. Okay, card number 3. Now we're going to move on to doing it on top of the grid. Okay, it gets a little easier because you are not dependent on the tracing paper anymore. Okay, let's use the same property that we said, that the distance of each of the vertex from the line of reflection is going to be exactly the same. Okay, it says to reflect the image across the x-axis. The first thing you need to do is, with the reflection, there's always going to be a line of reflection, and you need to define that. Where is the line of our reflection? It says across the x-axis. So which is the x-axis? Is it the horizontal one, or is it the vertical one? Hopefully you're telling me it is the horizontal one. Okay, so I am going to draw a blue line right over the line of reflection first so that it is really clear to me what we're dealing with. We're dealing with this line. So we're going to reflect this image over across the x-axis. And that means the distance for each of these image, the vertex distance, the perpendicular distance is going to be exactly the same. Okay, so I can start by drawing some points. Let me use red. Okay, so what is the corresponding point that to this vertex? It is 1 unit away from the line of the reflection, so I can put a point right there. What about this point? This vertex, it is 2 units, it's perpendicularly 2 units away, so I can put it right there. Okay, then I can draw a line across like so. So I have just reflected this section. What about from here to there? Okay, so this point right here is going to be 4 units away. So where is the 4 units away? 4 units away, so this is where the line is, and I'm going to move 4 units away from the line of reflection. 1, 2, 3, 4, and I am going to draw my point right there. Okay, so I have just reflected this portion. Okay, so that line is not very good. It's kind of a little bit diagonal, but I think you understand what I mean. Okay, then I need to find this point right here. That is 1, 2, 3, 4, 5 units away from the line of reflection. 1, 2, 3, 4, 5. And you can also find it relative to your previous point as well. And it's going diagonal. And then again it goes across. And then it goes down. So I can find each of the vertices by counting away from the line of reflection. This point right here is how many units, how many squares away? 1, 2, 3, 4. So it's going the opposite direction is going to be 1, 2, 3, 4. 1, 2, 3, 4 points away. So it's going to be this point. So I'm going to draw that line, joining that. And then I need this point right here is 1, 2, 3, 1, 2, 3, 4 units away, which is right here, and so on. Okay, so you're joining, putting the vertices and then joining, and at the end you should have something that looks like this. Okay, it's not the best drawing, but I think you get the idea what you should be doing. Okay, so this way we didn't have to use the tracing paper, did we? When we have the grid, it is much simpler. Okay, so then let's go on to the next one. Now this time it's asking you to draw in the blue line, that is y is equal to x, and then reflect the image across that line. Now this gets a little bit tricky, but let's try. Okay, the first thing we need to do is draw our line y is equal to x. From the beginning of the class, what did the y is equal to x look like? Was it a vertical line? Was it a horizontal line? Or was it a diagonal line? It was a diagonal line, right? With a slope of positive 1, or where x value and the y value were the same. So I can start by putting in some points here. When x was 1, y was 1. When x was 2, y was 2. When x was 3, y was 3, and so on. And those were the points when they had the same value, and I can join them by drawing a line through them. Okay, so first thing is this is my line of reflection. Now I am going to try to reflect this image across there. And I will continue with this in our next lesson recording. Thank you.